This is going to be the videos for the Unit 6 review. We're going to start with exponent rules. So we're going to have this problem here, and we're going to deal with the top on this problem first to make it look nicer. So it's 2 and then times 4. We're going to multiply those like normal to get 8. Then when we multiply exponents, we're going to add them together. So 3 plus 2 would give me x to the 5th. Then y to the negative 6 times y to the 4th. You're going to add those and you get y. Negative 6 plus 4 is negative 2. And then I'm just going to rewrite the bottom how we had it before. So 2x to the 4th y all to the power of 3. So remember, if we have power to a power, this power has to be distributed to every single thing on the bottom. So I'm going to leave the top the same until we're ready to deal with it. And then on the bottom, I'm going to have 2 to the 3rd power x. And then I multiply the two powers together if one is inside and one is outside the parentheses. So 4 times 3 would be 12. Then 1, remember there's a 1 on this y. 1 times 3 would be y to the 3rd. So then I have 8x to the 5th, y to the negative 2, all divided by. Now with this 2 to the 3rd, be careful that you don't do 2 times 3, because this is really 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. Then of course I have x to the 12th, y to the 3rd. So now we just have division. And with this I'm just going to divide everything. So 8 divided by 8, I divide those like normal and get a 1. 5 divide x to the 5th divided by x squared to the 12th, you're going to subtract. So 5 minus 12 is x to the negative 7th. And then I have y to the negative 2 divided by y to the 3rd. So this is going to be negative 2 minus negative 3. And remember, with minus and negative, that would become a plus. So negative 2 plus 3 would be y to the 1st power. And the only thing wrong with this problem is that we have a negative. And anytime you have a negative exponent, you have to move it down to the bottom. So we're going to have 1 y to the 1st power. Then that x to the negative 7 will move down to the bottom to become x to the positive 7. And that is our final answer. Now 1b is going to be the same steps. So I'm going to start by multiplying the top here. So I'm going to have 6 times 4 is 24. I'm multiplying here, so I'm going to add my exponents. So 6 plus 4 is x to the 10th. Then this is y to the 1st, so y to the 1st times y to the negative 3. 1 plus negative 3 is y to the negative 2. And then on the bottom, I'm just going to do this step now. So it's going to be 2 to the power of 2. 7 times 2, remember we multiply these, is x to the 14th. And then y1 times 2 is y squared. So then we get 24, x to the power of 10, y to the power of negative 2, all over 2 squared is 2 times 2, so that's 4. Then x to the 14th, y squared. So then 24 divided by 4 is 6. You subtract when you're dividing, so 10 minus 14, x to the negative 4. And negative 2 minus negative 2, again that becomes a plus. And negative 2 plus 2 is 0, so y to the 0. So then we get 6x to the negative 4. And then y to the 0 just turns into a 1. So we're just multiplying that by 1. But this really doesn't affect anything, so we're not going to worry about it. And now I just need to get rid of my negative exponent. So I'm going to bring that x to the bottom and make it positive. So 6 over x to the 4th is our answer. Alright, next two. This one we're looking at graph of exponential functions. So the first thing we're going to look for is our asymptote. And remember, your asymptote is where it's going to level off horizontally. So if you can see this line, it would continue on forever in this direction. And it looks like it's going to pass where y equals 2, but it actually never will. So this line right here that it looks like it's about to cross, but never will, is going to be your asymptote. So in this case, your asymptote is y equals 2, because it's at 2 right there. And make sure when you're talking about asymptotes, you should have it written like this, y equals 2. If you just write 2, that is technically wrong because it's not an equation. Now the next thing we're looking for is the y-intercept. So that's just where it's going to cross the y-axis, which would be right here. And it looks like that is at 3. But we have to write that as an ordered pair, so it's going to be the x is 0 and the y is 3. Remember, with your y-intercept, the x is always going to be a 0, and then your y is whatever value it will touch at. Now the domain for exponential functions is always all real numbers, no matter what. And lastly, our range, we have to decide, so we have this asymptote right here. And notice how this graph is completely above that line. So if this graph is above the line, it's going to be y is greater than. So above the line is greater than. And then we just look at what point our asymptote was at, which is 2. So y is greater than 2. Okay, this next one we're going to do the same thing. So our asymptote right here, notice where it levels off horizontally is right there. So our asymptote would be this line that I'm drawing, which is at 4. So we write y equals 4 for our asymptote. Remember, you have to have y equals. Now for our intercept, it's going to hit right here, which looks like it's at 3. So our y-intercept again is going to be 0, 3. You have to write that as an ordered pair. The domain isn't going to change because for every single exponential function, the domain is all real numbers. And then our range, if we notice here, the graph, so this line, is completely underneath the asymptote. So it will never go above it. So when it's underneath, it's going to be y is less than whatever our asymptote is, which in this case was a 4. So y is less than 4. So again, on this one, it's above the asymptote. That's why it's greater. This one, the graph is below the asymptote. That's why it's less than. Next, we're going to complete the table for the equation y equals 2 times 4 to the power of x. So we have to figure out what the pattern is to continue these on. And this number right here, our b value, is going to tell us what we're multiplying by each time. So times 4. So this number goes here. It's what you're multiplying by. So 0.125 times 4 gives us 0.5. And then we just have to keep this going. So times 4. So 0.5 times 4 is going to be 2. Then 2 times 4 is going to be 8. And 8 times 4 is going to be 32. So that is all you have to do. You just have to figure out what this rate that it's changing. You multiply the numbers by that number to get to your next values. And notice right here, this number out front we said was our y-intercept. And your y-intercept is when x equals 0. So when x is 0, your y should be 2, which is what we have. Next one, so let's fill this one in first. We know that our y-intercept should be a 1, so when x equals 0, y should be 1. But now let's try the pattern to see if that makes sense. So here, our rate is going to be, our growth or decay factor is going to be a 2, which means we should be multiplying by 2 on each of these. So 0.25 times 2 is 0.5. 0.5 times 2 is 1, which is what we got from the y-intercept. 1 times 2 is 2. 2 times 2 is 4. So that is our equation for these. And just for extra help, I'm going to label what everything is here. So this one is going to be growth, because we know that this number is bigger than 1. Our y-intercept is going to be 0, 2. And then our growth factor, that's your b value. So anytime it asks for a growth or decay factor, that's just this value that we're multiplying by. So that would be 4. And the same thing here. 2 is bigger than 1, so it's going to be growth. The y-intercept is the number out front. So this is going to be a 1. So 0, 1. And then our growth factor here is the number we're multiplying by, so it's going to be a 2. Now I'm going to skip 4a and 4b for now because I don't have the calculator on this computer, but I will post a separate video walking you through the steps of 4a and 4b. Okay, 5a wants us to do geometric sequences. So remember our equation for those is going to be a sub n equals a sub 0 times r to the power of n. So we need to figure out what a sub 0 is, so our 0 term, and we need to figure out what r is, and that's going to be our common ratio. So if we look here, we have 5, 10, 20, 40. So we need to figure out what are we multiplying by each time to get to the next number. So it's going to be times 2, times 2, times 2. So that tells us that our common ratio here is going to be a 2, which means our equation is going to be a sub n equals, we're going to leave our 0 term empty for now, but inside our parentheses, since this is times 2, this is going to be a 2. And it's always going to be to the power of n. Now to find our 0 term, we're going to have to go backwards 1. So the opposite of multiplying by 2 would be dividing by 2. So then we just have 5 divided by 2. So now 5 divided by 2, if you put that in your calculator, should give you 2.5. So 2.5 would be our initial value here. And that would be the equation that represents this pattern. Now the same thing with this one. So it's still going to be a sub n equals a sub 0 times r to the power of n. So then it's a sub n equals, we need to figure out what our r is. So here it's times 3 times 3 times 3. So when you multiply by 3, that means that our common ratio would be a 3 here. But now if I go backwards, I'm not multiplying by 3, I need to divide by 3. So 3 divided by 3 is going to be 1, which means our 0 term is 1. So that would be the sequence that represents that pattern. Now 6a says an adult takes 600 milligrams of ibuprofen each hour. The amount of ibuprofen in the person's system decreases by 19%. How much is left after 6 hours? So what we need to do is figure out what our equation is going to be. And remember, it's going to be y equals a times b to the power of t. And in this case, it's going to be a will be what we started with, so our initial value. And b is going to be our growth or decay rate, our factor, I mean. But notice here we have a percent. So that's actually going to change our formula just a little bit. So I'm going to erase this. Remember, whenever we have a percent, it's going to be y equals, still going to be a, but then it's going to be 1. And now this one is decay. Decreasing means it's decay. So it's going to be 1 minus r to the power of t. So now we just need to figure out what a and r are so we can figure out our equation. So a is always going to be the amount that you start with. So if we read this question, it says we start with 600 milligrams. So our a is going to be 600. A is always the initial amount that you have. Now r is going to be the rate that it decreases by. And remember, we're subtracting because it's decay by decreasing. So r is going to be 19% here. But we can't leave this as a percent. We need it as a decimal, which means we move it over 2 places and we get 0.19. So now we can fill in our formula here and get y equals, remember a is our initial, so 600 times 1 minus 0.19 to the power of t. And then when we subtract 1 minus 0.19, we get 600. 1 minus 0.19 is 0.81 to the power of t. So that's our first part. That's the equation. But now it wants to know how much is left after 6 hours. So that means that our t here is going to be 6 hours. And I replace it. So instead of a t, we're going to have 6 because we're looking for 6 hours. So now all we have to do is plug it in the calculator. See what we get. So be careful if you're putting this in your phone calculator. It may not give you the right answer. So when you put in the calculator, you get 169.45772. And now we don't really need all of these decimal places. We're just looking for only 3. So 169.45. Then we can round this 7 up to an 8. So that would be the answer we need. Our next question says, you drink a beverage with 120 milligrams of caffeine. Each hour, the caffeine in your system decreases by 12%. How much caffeine is left after 5 hours? So again, this is decreases, so it means it's going to be decay. And our equation will be y equals a times 1 minus r to the power of t. This minus right here is very important when it's decreasing. If it's increasing, it would be a plus. So our initial amount that we start with here is going to be our 120 milligrams. Then our rate is 12%. But we need that as a decimal, so move the decimal place over 2. We get 0.12. So y equals Our A is 120. 1 minus 0.12 to the power of t. And we simplify that, so we get y equals 120, parentheses, 1 minus 0.12 is 0.88 to the power of t. Now this one wants it after 5 hours. So we're going to replace the t with a 5. So y equals 120 times 0.88 to the power of 5. And then put that in your calculator. And you get 63.32783. But we only need 3 decimal places, so y equals 63. We're going to take this 8, and that's going to make this 7 round up to an 8. So 63.328. Now, if this was money, you would need to make sure that you only have 2 decimal places. And if it was a living thing, you should make sure that it is a whole number. Okay, 7 wants us to fill out the information based on this exponential function. So our growth or decay rate, initial value, and it just wants to know if it's growth or decay. So if we look at this here, we know that this right here is our A value, and this right here is B, or our rate. So growth or decay, we have to look at our B value, and looking at that, it's 0.5. So whenever it's less than 1, but greater than 0, we know it's going to be decay. So since that is a decimal there, it's decay. And our initial value, that's what we start with, is always our A value. So our initial value here is 12. But that's going to be, if it asks for a y-intercept, you would have to write it as 0, 12. But since this says initial value, you can just leave it as 12. Be careful though, if it does ask for a y-intercept, you have to write it as an ordered pair. Then our growth/decay rate, so we know it's not growth. So our decay rate is going to be whatever the b is, so 0.5. And that's all you have to do on these. So same here. Notice this one. This is our A. This is our B. And since our B value is greater than 1 this time, it's going to be growth. Our initial value is going to be 100 because that's our A value. And then our growth or decay rate, that's just whatever your B is, so it'll be 2. Now with 8a, it says Denver's population is currently 124,900. If the population doubles every 25 years, what will the population be 100 years from now? So the population is currently 124,900. So that means that's going to be our initial value. So our equation here, notice it is increasing because it's doubling. That is increasing. So our equation is going to be y equals a times 1 plus r to the power of t. Increasing means there's a plus here. Actually, on this one, we don't need that because there is no percent. Sorry. So it'll be y equals a. We're just going to have a rate here. So b to the power of t. Notice it doesn't have any percent at all. So our a value is going to be y equals 124,900. That's our a. Then our b value, notice it says doubles. So doubles means you're multiplying by 2 every time. So our b value is just going to be a 2. It's not going to be 1 plus or 1 minus here because it's not a percent. The only time we do the plus or minus is if we have a percent that we're gaining or losing. And then it'll be to the power of t. Now to figure out what the population will be 100 years from now, we know it doubles every 25 years. We have to figure out how many times it would double in 100 years. So after 25 years it doubles, that's once. Another 25 years would be 50 years, that would be our twice. Another 25 years would be 75 years, so it would double 3 times. And then another 25 years would be 100 years, meaning it would double 4 times. So you can take the 100 years, divide by 25, and that will also give you the 4. Which means our t value here will be a 4. So y equals 124,900 times 2 to the power of 4. Now if we put that in our calculator, you will get y equals 1,998,400. So that would be the population of Denver after 100 years. So anytime it doesn't have a percent, you are not adding or subtracting 1. Now this one here says Markel deposited $610 in a savings account, earning 15% interest compounded annually. To the nearest cent, how much interest will he have in 5 years? So interest, that tells us this is going to be a growth problem. So this one will be y equals a times 1 plus r to the power of t. And our a value is what we start with, so the amount of money he deposited to start would be 610. And then our percent here is 15, so it'd be 1 plus 0.15. So 15% as a decimal is 0.15 to the power of t. Anytime it's increasing, you have to add this 0.15. So y equals 610. 1 plus 0.15 is 1.15. And it wants to know how much you would earn after 5 years. So y equals 610 times 1.15 to the power of 5. So our answer here is 1,226.927888. But this one is about money. So we can only have 2 decimal places. And notice there's a 7 here, so we're going to have to round up. So it'd be 1,226.93. So that is the total amount that Markel would have saved after 5 years. But this question also has one added thing. Your test may not have this. It says how much interest will he earn in 5 years? So this is something you see on IXL. Whenever it asks how much interest, so the question has to ask how much interest, not every interest question in general. So if the question is asking how much interest he will earn, you have to take the total amount he has after 5 years and subtract the amount that he started with. So it'd be 1,226.93 minus 610. So when you do that, you would get $616.93. So that would be the interest, and this one would be the total amount. So make sure you're looking for what the problem wants you to answer. And that is it for this Unit 6 review. Like I said, I will post those 2 regression questions as a separate video.